Hey guys, Mrs. Croft here. Welcome to your second lesson. Today we're going to talk about dividing radicals and rationalizing the denominator using the conjugate. Now I know there's a lot of vocabulary in there, but don't worry, it's really not that bad. Alright, if you're up to the challenge, because this is a really difficult warm-up, if you're up to the challenge, go ahead and pause your video and try this warm-up. If you're not really up to the challenge, go ahead and we can get right started on the notes. If you tried the challenge, there's your answer. Hope you did well. All right, and let's get started. Today we're going to talk about dividing radicals. Now, when you divide radicals, if you have the same index value, you can split it up either into the square root of the numerator and the square root of the denominator, or you can just divide first and then do the square root. So sometimes it's more beneficial to divide it out first and then simplify using your radicals. So we're going to look at the square root of 243 over the square root of 27. Now, if you happen to do 243 divided by 27, it happens to come out nice. It happens to work out to be 9. So this is really the same as the square root of 9, which we know. That's 3. That was a lot simpler than trying to simplify the square root of 243 and the square root of 27. Both are perfect squares. Same thing's going to happen in B. If I divide 12x to the 4th by 3x and then do the square root, it's going to work out a little bit easier for me. So if I reduce this, it's going to end up being 4x to the 3rd. Oh, where did x to the 3rd come from, you ask? Remember, when you divide like bases, you subtract your exponents. Now, 4x to the 3rd we can simplify. 4 is a perfect square. So that's going to come out as a 2. So think back to our last lesson when we simplified with variables. Okay, we're going to be left with an x on the outside and an x on the inside. So this happens to be 2x times the square root of x. For these next two examples, I want you to divide first and then simplify the remaining radical. And when you're ready to check your answers, you can replay your video. Okay. How'd you do on C and D? C was pretty easy. I think you guys probably did really well on that one. D was a little trickier because you had to work with the cubed root. So you had to draw back into your cubed roots. So hopefully you did well on both of those. All right, let's take a look at the next examples. Now, one of the rules that we have to work with rationalizing the denominator is the fact that you can't just leave a radical in the denominator. So we go through the process of what's called rationalizing the denominator. It's pretty easy. If you have the square root of 5 in the denominator, you're going to multiply by the square root of 5. Now, notice I'm going to multiply the denominator and the numerator. In reality, I'm just multiplying by 1. I'm not changing the value of my radical at all. Now, if you'll remember from our other lesson, we're allowed to multiply radicals together. So this ends up being the square root of 60 over the square root of 25. Now, some of you are probably saying, but wait, Mrs. Croft, you still have a radical in the denominator. But it's a perfect square now. So now I can change this to a 5. And at the same time, I'm going to simplify the square root of 60 into 4 times 15. So the square root of 4, it's perfect square. It's going to come out as 2. And we're going to get a nice answer of 2 radical 15 all over 5. Okay, now let's take a look at putting a variable in there. Same thing as before. You just multiply by what the radical is in the denominator and make sure you multiply the numerator and the denominator. So this is going to now give us the square root of 40x over the square root of 64x squared. Now remember, we're creating a perfect square in that denominator. So that just happens to be 8x. And if I go up to my numerator, I can change this into 4 times 10 times x. 4 is a perfect square. So that comes out as 2. So now I have 2 times the square root of 10x all over 8x. What I want you to see here is the 2 in the numerator and the 8 in the denominator are going to be able to reduce. So my final answer is going to end up being the square root of 10x over 4x. Right, notice I didn't reduce the 10 and the 4. I didn't reduce the x's. That 10x is inside that radical. I cannot reduce with that denominator. That radical has to stay the square root of 10x. Okay, I think you're ready to try a couple on your own. So go ahead and do C and D, and when you're ready to join me again, press play. Okay, how did you guys do? The first one was pretty easy. Second one wasn't too bad either. Okay. Now, something I want you to notice, if you look here, whatever you're multiplying by, okay, so we have 8y and 8y, you create this perfect square here. And then when you take the square root of it, it just ends up being whatever you started with. So some of you may be able to start taking shortcuts and realize that, hey, when I create a perfect square and then turn around and take the square root of it, it's going to give me back what I started with. All right, now, this one is a little more difficult. And I'm going to save these examples for class. So if you're interested in finding out how to simplify a perfect cube in the denominator, see me in class. Okay, otherwise, we're going to move on. All right, the conjugate. This concept is pretty easy. The one thing that you're going to want to remember is that you have a sign that you need to change. So if you look down at example A, those two binomials are conjugates. Notice the difference in the signs between the two parentheses. That's the only difference if you're with your conjugates, is the sign in the middle. Now, if I multiply a conjugate, something special happens. So let's multiply this out. So we have 1 times 1. Then we're going to get minus radical 7 plus radical 7 minus the square root of 49. All right, anybody notice that these two terms in the middle are going to cancel out? Anybody else notice that this happens to be a perfect square? So I end up with 1 minus 7, which gives us a negative 6. So we took two binomials, both of which involved a radical, multiplied them together, and just added up with and ended up with a nice integer value. So that's something that happens when you multiply conjugates together. So let's take a look at B. Let's multiply it out. Okay, so we have 5 radical 3 times 5 radical 3. That's going to be 25 times the square root of 9. Now you're going to have, remember, you're allowed to multiply radicals together. And what's going to happen, and some of you are going to start to be able to realize that you can take a shortcut, your middle terms are always going to cancel when you multiply conjugates together. So if you realize that pattern by now, you can go ahead and start taking that shortcut. We have two perfect squares here. Okay, square root of 9 is 3, so this just ends up being 75. And the square root of 4 is 2. So we have 75 minus 2, which is going to give us a value of 73. So again, if you're multiplying an expression and its conjugate together, your final answer is just going to come out to be a nice integer value. So now that we've gotten to example 4, I know some of you are dying to know how we get the square root of 3 out of the denominator, because as you remember, you're not allowed to keep radicals in the denominator. So when you have an expression in your denominator, in this case we have 2 plus radical 3, you need to use the conjugate. So you're going to multiply by 2 minus radical 3. And because we've got to do it to the denominator, we've also got to multiply it to the numerator. So we're going to have 10 minus 5 radical 3. Now remember, in the last examples, we talked about multiplying the conjugates together, and their middle two terms always ended up canceling. So I'm going to save myself a little bit of work, and I'm only going to multiply my first terms and my last terms, because I know that when I multiply conjugates together, the middle terms cancel. So this gives me 4 minus radical 9. All right, but we know that the square root of 9 is 3. So this is really just 4 minus 3. So now we have 10 minus 5 square roots of 3, and I really don't need to put it all over 1. So there's my final answer. All right, in part B, I'm going to get you started, and then you're going to finish it on your own. So the first thing we're going to start off is the conjugate. So what's the conjugate? of 1 minus radical 5. Good job. 1 plus radical 5. So we're going to multiply the numerator and the denominator by 1 plus radical 5. Alright, so now that I've got that set up for you, I want you to go ahead, pause your video, and finish this question out. Okay, so I've gotten to a point where I multiplied out in my numerators, I multiplied my conjugates, my denominators, and I ended up with 6 plus 2 square roots of 5 all over negative 4. And something that I want you to notice is that this negative 4, this 2, and this 6 can all be reduced by 2. So I'm going to go ahead and reduce each one of those by 2. So this is going to give me a final answer of 3 plus radical 5 all over negative 2. Okay, I'm going to start you off with your conjugate, but then I'm going to leave it up to you to finish up the question here. So let's take a look. What's the conjugate for C? Nice. 2 radical 3 plus 4. 2 radical 3 plus 4. Right? Go ahead and distribute your 2 in your numerator. Multiply your denominators together there. And then play your video when you're ready to check your answer. Okay. How'd you do on C? Now, if you had left your answer as 2 plus radical 3 over negative 1, I totally would have given you full credit for that. Okay? I moved the negative to the numerator and then distributed it to each term. So either one of those answers would be perfectly fine. Alright, your conjugate for this one, remember you're just changing your sign. So this is going to be radical 7 minus radical 2. And radical 7 minus radical 2. Alright, there's a lot of radicals there. Be careful as you're multiplying. Take your time. Join me when you're ready. Wow, that one had a lot of radicals. It had some like radicals. It had a lot of simplifying. That one was tough. So if you got down to the square root of 2 for your final answer, that is pretty impressive. Okay? I went through step by step there. I took a couple shortcuts along the way, so if there's any questions on that one, make sure that you mark it so we can go over it in class. Here's some more extra practice for you. These questions, I think you guys can definitely handle them. Just be very careful about your simplifying. Really watch your multiplying. Watch your combining of like terms. So if you want to, go ahead and give these two a try. If you want to wait until class and ask me about them, that's fine also. Go ahead and pause your video if you want to give them a try, and then join me when you're ready. Alright, if you chose to do these two, they were a little more challenging. So if you've got to the point where you can simplify these, then you are doing awesome. Not that the rest of you aren't doing great. You are. Everybody's doing awesome with this. That's the end of this lesson. Okay, so next class, we'll be definitely practicing some of these. These are the types of questions that is once you start getting into the process of it and recognizing your conjugates, figuring out a little shortcuts here and there, these questions really aren't that bad. So I look forward to seeing you guys in class so we can practice these.